or you can save these basic commands in a text file on your system somewhere. Change directory. Percentage CD is the syntax. Percentage is the syntax you have to use for directory changings, magic commands. They are all magic commands. So what happens is we have a set of commands called magic commands, which are active during the sessions. They are not permanent. They will be active during the sessions. And once you close the session, it will get inactive. You have to activate again. Use of magic commands is to make the process faster. Otherwise, what happens is there are exceptions also that are there in magic commands. When we study programming, then we will know about these magic commands in detail. There will be sessions on programming. That time you will understand that. Yeah, all of you inputted the data. Done, all of you have imported. Anybody has any issues? What's happening? What is the issue? Yeah, that's why you have to save the path directly. You have to do it in two different cells. You're doing it in one cell. How did I do it and how did you have to do it? Remove it. See, without setting the path, how will you use it? You didn't copy any question correctly. The path has to be correctly copied. Not from here. It has to be copied from security tab. Object names. Wait a second, don't copy the file name. Security object tab, not the location. And it is double quote, not single quote. As well as the Windows laptops have to use double quotes. Windows laptops have to use double quotes for paths. Macs use single quotes for path. All right, all of you are done. Anybody else has having problem? So once we have imported the data, we use the info command for looking at the row numbers, variables and the data structure. The data structure is data frame 0 to 730 observations. 16 variables are there. And if you come down, 4 are float, 11 are integer, 1 is object. So you have different variable types here. And then you can see each variable type. Now run the head and tail commands on this. Run head, tail, and columns. Head, tail, and columns of the data frame. Bicycle data dot head. columns does not have brackets. Columns is exception, use dot columns. For all functions, there is brackets except shape, D types and columns. D types and columns. For all functions, there must be parentheses. Only three exceptions are there: shape, D types and columns. Every function must have parentheses. Which one? Extend and yeah, we can use. They are mutable, right? You can use. Yes. That is all will be discussed in programming. Python programming will be a different session. That time will be discussed. Basics. See, if I start discussing programming, you will go out of things. So we are not bothered about programming here. We are more bothered about the data science. Python programming is different. We will just introduce you to Python programming with couple of sessions. If you want to do Python programming, there is something called full stack Python, which is a completely different course. Full stack Python is a completely different course, which is purely Python programming. The curriculum here is purely data science. Only couple of sessions which are basic requirement for programming in data will be discussed. Because in industry, Python programmer is a different profile completely. Python programmer is a completely different job description. You have to study full stack Python, which is a completely different. For full stack Python, you must know Java, you must know C, and you must know Unix. That's full stack Python is a different program where you will go into data structures in depth. In dictionaries only, we have to discuss iterators, and there you will get all sorts of discussions, iterators, classes, modules, and dictionaries and all. So we will not discuss programming here. This is only focused on data science. If you are interested in programming, you have something called full stack Python. You have to study full stack Python. That's a different job profile, which is different from basic Python for data science. So this is the full stack Python curriculum. You can look at it. Pure programming related. So we will be focusing on data science and little bit of programming related to data science, which you are expected to know as data scientist, as data analyst. We will not go in depth. A Python programmer has to deal with dictionaries to extend, because you can't simply extend a dictionary. You have to write an iterator. You have to use a for loop with multiple arguments to write an extension for dictionaries. So all those things will be discussed. If you are this is the full stack Python program. So only relevant concepts, because when you are working on data, you will be focusing only on data. Programming, you will have a Python programmer who will assist you with terms of programming related tasks. So the magic commands, the syntaxes, everything which you are talking about, which we are discussed in programming only, pure play Python programming. We have couple of sessions on programming related to for loops and some loops which we use in data science. Basically in industry, that also is done by programmers only, but if you know it, it's better you can write your own loop rather than waiting for a programmer to write a loop and send it to you. So this curriculum is purely data science. We will focus only on mathematics and statistics only. The tool is just an additional part. Whether it is R or Python, you must know the statistical and mathematical concepts. The tool can be anything, R, Python, SAS, it can be Julia or anything. But the data science algorithms are same. The basic statistical concepts are same. That you need to have understanding as per this program curriculum. Okay, all of you are till here. Now, the first step in any data science project is the exploratory data analysis, which is EDA. It has your descriptive statistics, data visualization, and data aggregation. The three components of EDA. EDA provides complete understanding of data and aids in pre-processing. So EDA will give you the complete understanding of the data. What are the problems? What type of variables? What are the patterns? What are the trends? What are the structures? Everything will be known in EDA. And accordingly, based on EDA, you will start your data pre-processing. The pre-processing will be done according to the EDA, whatever EDA points out to. Within descriptive statistics, describe the nature of the data. As the name suggests, describe the nature of data. For numeric variables, we can do univariate statistics. Univariate statistics for numeric variables. The various things which you can do is count, minimum, maximum, count, minimum, maximum. Then you have your measures of central tendency. Measures of central tendency being your midpoint of the data. What are the measures? The mean, the median, and the mode. Then you have your measures of dispersion. Dispersion is scattering of observations around mean. Scattering of observations around mean. The metrics are variance and standard deviation. Then you have your measures of location. Which are quartiles, percentiles, and deciles. Then you have your measures of asymmetry, which is skewness. Asymmetry is how close data is to normal distribution, or bell curve. They are skewness and kurtosis. So in exploratory data analysis, the first and foremost is descriptive statistics. descriptive statistics on numerical data, only on numerical data. We call them as univariate statistics. Univariate means single variable. They are calculated or computed on individual variables or single variable. The descriptive statistics include count, minimum, maximum, measures of central tendency, the mean, median, and mode, measures of dispersion. Scattering of dispersion means scattering of observations around the mean, variance and standard deviation. Measures of location, where the data is located in first quartile, second quartile, or third quartile. Percentiles, whether it is in top 20%, bottom 20%, top 30%, bottom 30%, like that. And measures of asymmetry, how close the data is to normal distribution, also called as bell curve. Skewness and kurtosis. So these are the basic metrics, descriptive statistics, which we need to compute on each of our numeric variables. So if you are looking the formula of mean, what is the formula of mean? Sum of numbers divided by count of numbers. N represents number of observations. In statistics, N or small n represents count of observations. What is the formula for median? Sort data in ascending order. First, you need to sort the data in ascending order. And if n is odd number, exact mid value. Exact mid value is median. And if n is even number, you will have two mid values, m1 plus m2 divided by 2. But first you have to sort the data in ascending order, smallest to highest. And if the number of observations is odd, exact mid value. If it is even, you will have two midpoints, m1 plus m2 divided by 2. Brackets in the wrong place. What is mode? Most frequent or most repeating. Most frequent or most repeating. This is your mode. Now, whenever you look at your descriptive statistics, you always look at mean and median. Mean and median must be calculated for numeric data. If you are calculating mean, you also must calculate median. Why? Because if there is a big difference, between mean and median, then the data is skewed with outliers. So whenever you look at mean and median, they must be closer to one another. Not exactly same, they must be closer as much as possible. Take for example, if mean is 50, I want the median plus or minus 10. Either median should be 40 or median should be 60. If median is 20 or if median is 80 and mean is 50, that means there is a big difference between mean and median, and mean is getting distorted. So median does not get distorted, mean gets distorted mean gets distorted by larger values or smaller values. You have to be very careful when you are looking at this data. Now, take for example, what I'm talking about is print np.mean let us say I have conducted a test and people scored these marks. So if I calculate the mean, so what is happening here? Oh, sorry, I have to give it in vector. It has to be in vector. So the mean is 80. Is it correct? Formula wise, it is correct. But 80% average for the students, is it the correct representation of the data? Because majority of the students scored above 90. But because of the two students who scored very less, the whole mean is got distorted. Mean is not giving us the right picture here. Formula wise, mean is correct. But is it giving you the correct picture of the data? 3 out of 5 students scored above 90. So for the same data, if I calculate median, median is 90. Now, which is giving me the right representation of the data? Median is giving me the right representation of data. So the problem with mean is it gets affected by the smaller values or higher values. So always check mean and median. They should be closer to one another. If there is a huge difference between mean and median, you will consider median as your midpoint, not mean. Because mean will not give you the right representation of the data. Median will give you the right representation of the data. When there is a big difference between mean and median, use median as your midpoint. You have to use median as your midpoint. Clear? So basically the interpretation is here is if mean is distorted, median must be used as midpoint, must be used as central tendency. Any doubts, participants? You have to copy from Google. So I have given you the meaning of the terms in the brackets. Central tendency means midpoint. Dispersion means scattering of observations around mean. Asymmetry means how close is data to normal distribution or bell curve. The definition of the terms is given in the brackets. Go to Google, search for the symbol and test it. Got it? Any doubts? Central tendency? So these two are the outliers. These two are the outliers. Outliers means if they are on the left side, they are weak performers. If they are on the right side, they are good performers. If they are on the right side, they are highest values. If they are on the left side, they will be the lowest values. In this case, the 60 to 65 marks students are worst performers, which is affecting the whole class average. So in this case, what gives us the right representation? 90. Okay. Now, let us go to the next set of measures, which are your dispersion, scattering of observations around mean. Variance. The formula of variance is equal to sigma observation minus mean to the power of 2 divided by n minus 1 or n. Now here n represents population and n minus 1 represents sample. In statistics, n represents population, capital N or small n, n minus 1 represents sample. Now you can calculate population variance, the denominator will be n minus 1. If you are calculating population is n, sample is n minus 1. Formula is sigma x minus mean whole square. X minus mean whole square divided by n minus 1 for sample or n for population. So basically what we are trying to do is, what variance is doing is, if you have a mean, it will try to find the scattering of observations around the mean. That is what the formula is. The formula finds how the data is scattered around the mean. Let us say this is our mean and these are our observations. If they are all scattered close to mean, variance will be less. If they are scattered widely around the mean, variance will be higher. So these are the observations with the midpoint. How the observations are scattered around the mean. If they are very close to the mean, variance will be smaller. If they are far away from the mean, variance will be higher. Dispersion means scattering of observations around mean. This is one of the common interview questions. What is variance? Is it mean or median? Median. It is mean, not median. And then standard deviation. What is standard deviation? Square root of variance. Square root of variance is standard deviation. That means if you add square root to this formula, standard deviation, square root of variance. Square root of variance. There is no fixed range. Lower the value, better. So for variance and standard deviation, we don't have a fixed range. Lower the value, the better. All right. Now the location measures, quartiles, sort data in ascending order. Sort data in ascending order. Q1 or 25% is equal to n divided by 4, number of observations divided by 4. Q2 or 50% or median. Q2 also called as second quartile or 50% or median is equal to 2n divided by 4. Q3 third quartile or 75%, it is 3n by 4. And Q0 is minimum. Q4 is maximum. Q4 is maximum. Quartiles, fixed values. Quartiles will divide the data into 4 equal parts. So basically, quartiles divide data into 4 equal parts. But the data has to be sorted in ascending order first. Deciles. Deciles are multiples of 10. Same formula. Deciles are multiples of 10. 10%, 20%, 30%, like that. And percentiles, you give a specific value. So percentiles are top 10%, 20%, 30%, like that. Percentiles will be any specific value, 88%, 38%, 44%, like that. If you want a specific value, we will do the percentiles. Then you have a symmetry. The first is skewness. The mathematical symbol is important. Positive skewness, peak of the curve on left side, and negative skewness, peak of curve on right side. I'll just show you the graphical representation. Let me complete the other one also. Kurtosis. For kurtosis, 3 is the value. Less than 3 is negative kurtosis, which means the peak will be flat and wide. Greater than 3 is positive kurtosis. The peak will be tall and narrow. Peak will be tall and narrow. Now, skewness and kurtosis relate to the normal distribution. How the data is, how much is the data closer to normal distribution. So you can see here, positive skewness. The peak is onto the left side. Skewness 0, normal distribution or bell curve. Normal distribution or bell curve is skewness 0. Skewness is negative. The peak is onto the right side. Similarly, kurtosis less than 3 is negative kurtosis, flat and wide peak. Skewness, kurtosis is equal to 3 is normal distribution or bell curve. Skewness greater than 3, tall and narrow peak. Tall and narrow peak. So this is the interpretation of skewness and kurtosis. For skewness, the mathematical sign is important. For kurtosis, we compare the value with 3. Is equal to 3 is normal distribution. Less than 3 is negative. Greater than 3 is positive. Skewness and kurtosis, how the peak looks like. Because one of the most common assumption in statistics is normal distribution or bell curve. For doing some set of calculations, the numerical data must meet the assumption of normal distribution. For some calculations and some computations in statistics, the numerical data which we are going to use must meet the normal distribution assumption. But normal distribution is a hypothetical situation. It doesn't happen in real life. So what we try to do is we try to bring data as much as possible closer to normal distribution. We will look for data, we'll try to bring data as much as possible closer to normal distribution. Because perfect normal distribution is a hypothetical situation which does not happen in real life. We will try to bring data as much as possible closer to normal distribution. Sometimes we cannot bring the data closer to normal distribution. No matter what we do, what method we try to do, or what transformation we try to do, data will not be brought to the normal distribution. Then we have algorithms and models that work on data that is not normally distributed. So we have algorithms that require data to be normally distributed. We also have algorithms or machine learning models that does not require data to be normally distributed. So if we can't bring data to normal distribution, then we will use different algorithms that are not affected by this normal distribution assumption. We have those algorithms also which are used when data is not normally distributed. So how we know the distribution? Based on the skewness and kurtosis. Based on the skewness and kurtosis, we will come to know whether the data is normally distributed or not. Or if it is not normally distributed, how far it is from normal distribution. Can we employ any strategy for bringing the data to normal distribution? There are some transformation which I'll discuss right now, which we'll try. If it brings, it's okay. If it doesn't bring, we have to look for algorithms or models that are not affected by the normality of data. Any doubts in the basic descriptive statistics? These are the basic descriptive statistics. See, once you run the descriptive statistics, you must understand those numbers. They are not simply output. You have to interpret, you have to understand, then only you will be able to move forward. Simply printing the output doesn't make. You have to understand what those numbers from. And most of the times, when you print the outputs, you will find the initial problems. What are the problems? If mean and median are far, you know the data is skewed. Outliers are there. Outliers are extreme values. So you should mentally prepare yourself for tackling that issue. If you see missing values, the count is less than the actual count, then you should be ready for doing missing value imputations. If you see different mathematical units, you should do data transformation. So these descriptive statistics will hint to a lot of issues which you will be facing in the next step of pre-processing. So people don't understand these numbers, they can't do pre-processing correctly. If you understand these numbers, you will be able to do pre-processing very fast and very clean, and the success rate of your machine learning models will also be high. Okay. So all of you, the day.csv Excel, the CSV file which I sent you, open that file. Open the day.csv file. Open the day.csv file. File, save as, change the file format to Excel workbook. File, save as, change the file format to Excel workbook. Because in CSV files, you can't save the outputs. So convert the CSV file. File, save as, file format or file type. Change it to XLX workbook, the first option. Change from CSV to Excel. All right, all of you change the file format to Excel workbook. Excel will open in the system. I didn't save it. Okay. Two, 4, 4, 2 only, right? Yes, I sent it. So all of you open the Excel file. So copy the data of CNT. Control Shift down arrow, Control C into a new sheet in the same workbook. CNT. Copy the data of CNT into a new workbook. CNT. The last variable. Count of bikes. CNT is short form for count of bikes. Count of bicycles rented. Copy the column. Control Shift down arrow, the column. Down arrow should be pressed only once. It will automatically select the data range. Paste it in a new sheet in the same workbook. And then we will calculate the descriptive statistics. So I didn't give you skewness and kurtosis formulas, right? Skewness and kurtosis formulas. X minus mean whole cube divided by n into s cube. S is your standard deviation. X minus mean whole cube divided by n into s cube is skewness. X minus mean to the power of 4 divided by n into standard deviation to the power of 4 is kurtosis. This is the formulas for mean skewness and kurtosis. Okay. Now for the count, what is the function? Is equal to count. You can type small letters. Go to the first cell, B2, Control Shift down arrow, B732. I think the last observation, close bracket, enter. So the data range is B2 colon B732. You can type is equal to count. You can type small letters, open bracket, B2 colon 2 dots, B732, close bracket, and enter. Count function is equal to count, open bracket, B2, you can type small letters, no problem, colon B732. count or n. Number of observations we have is 731. Is equal to count. You can type small letters. Excel is not case sensitive. You can type small letters. It will automatically convert it into capital letters. Is equal to count, open bracket, B2. You can type B2 small b2 colon 2 dots B732. Close bracket, enter. Like this. Is equal to min. Open bracket, B2 colon B732. Once you know the data range, you can type. Once you know the data range, you can directly type. No need of selection. Is equal to max. B2 colon B732. Is equal to min is for minimum. Is equal to max is for maximum. B2 colon B732. Range is max minus min. Max minus min is range. That means select the cell where you have calculated max minus select the cell where you have calculated min. Check your column name. My data is in column B. Check the name of the column in which you have. My data is in column B. Only numbers, don't select the header. Only numbers. Don't select the header, only the numbers. All of you are getting this? Got this? All right. Now, there is no mean function in Excel. It is average. Is equal to average. Open bracket. B2 colon B732. Is equal to average. Open colon, open bracket. B2 colon B732. AVRAGE, average. There is no mean function in Excel. It is average. So average is 4504 point something you will get. Is equal to average. Got it? What is the value got? 4504, right? Now, what is the formula? Is equal to sum of B2 colon B732 divided by count of B2 colon B732. Sum of numbers divided by count of numbers. That is the statistical formula. We will get the same value. Sum divided by count is equal to sum of B2 colon B732 close bracket divided by count of B2 colon B732. Sum divided by count. Mean formula. Sigma n by n. Yeah, we will be doing in Excel only. Because even advanced calculations, complex calculations, we will be using only Excel. Even the algorithms calculation will also be done Excel because manually calculating it is difficult. In Excel, you can do it easily. Pen and paper calculation is also similar only. You need scientific calculators and all for that, but or you can use a laptop-based scientific calculator. That's not a problem. But Excel would be the best option. Same formula, right? Sigma n by n, which is nothing but sum of numbers by count of numbers. Got it, all of you? Average. Now, for median is equal to median open bracket B2 colon B732 is equal to median open bracket B2 colon B732 close bracket enter. So median is 4548 is equal to median open bracket B2 colon B732. Got it? Now, what is the formula? N by 2. N by 2 is the formula. That means 731 divided by 2. 365. 365th observation is your median. 365th observation will be your median. But what we have to do first? First, we have to do what? You have to go to Home tab, sort and filter, smallest to largest. Sort the data from smallest to largest. Select the numbers, go to Home tab, sort smallest to largest. Ascending order sort. Select only numbers. Don't select the CNT. Select the numbers. Go to the Home tab. Right extreme corner, you will see sort and filter. Click on sort smallest to largest. Okay. Then it will sort the data from smallest to largest. Select the data. Don't select the header. Go to sort and filter in the Home tab, smallest to largest. right? Ascending order. Now, control G, control G, you have to go to cell number 365. It says reference not valid. This ascending, smallest to largest. Go to, oh, in Excel, in this notes, constants, formulas. Okay. So, or else you can scroll down to row number 365. Row number 365, the value is how much? 4539. You got 4548. Huh? So 367. 365 round off is somewhere 367 is coming as 4548. But it is 34541, right? Acha, 366 only. Yeah, because we are one cell down, right? So if you round this off, 366, row number 366 value. 4548. Got it? N by 2. Rounded off is 366. 367th row means we are starting from 2, right? Row number 2. Values are starting from row number 2. So 366 cell is 4548. Median N by 2. Because this is odd number, right? This is odd number. We got the exact mid value. Is equal to mod B2 colon B732. 107996 is repeating number. All right, all of you got this? Now, what is formula for variance? Sigma x minus mean whole square. Sigma x minus mean whole square divided by n minus 1. So we have to calculate x minus mean to the power of 2. we have to calculate x minus mean to the power of 2, which means is equal to open bracket 22 minus, we have already calculated the mean here. Now mean is constant for all, so you have to press Fn plus F4. On your left side of the laptop, you see Fn button. Fn plus F4 will create two dollar signs. We call it as absolute cell referencing. Even if we drag the formula, the cell will not change. Generally, what happens if the formula is dragged, the cell also will drag down. To stop it from doing it, we are inserting $2 signs. That we call it as absolute cell referencing. Absolute cell referencing will fix the cell. It will not move even though you drag the formula. Mean is common for all the observations. So that means F6 has to be constant. F6 has to be constant. By pressing Fn plus F4, Fn plus F4, $2 signs will be inserted. Close bracket to the power of 2. X minus mean whole square. You will get the value. Now you have to simply double click the formula. It will calculate for all the observations. X minus mean whole square, you have to calculate. Is equal to open bracket the x value minus mean, the average value. Fix it by pressing Fn plus F4. In most laptops, it is Fn plus F4, or it is F4 directly. I think in all the laptops, it should be Fn plus F4. Very old laptops, it will be F4 directly. We call it as absolute cell referencing. The cell will be fixed. It will not move. But the rest of the cells change. Except the mean cell, X value has to change. And then double click on the bottom corner dot of the cell. It will calculate for all. All right. Is equal to sum of C2 colon C732 divided by count of C2 colon C732 minus 1. I'll also calculate var directly. See, the function is var dot p. Again, dot p is population, dot s is sample. See, in Excel, you will see for some formulas dot p. Dot p is for population, dot s is for sample. Now, if you look at the var formula, you have var dot p is equal to var dot p. That is the one I am using here. Var dot p is for population, var dot s is for sample. Now you can see here the population var B2 colon B732. I am using the function first, var dot p B2 colon B732. Okay. Now the formula. The formula is this: sum of x minus sigma, right? Sigma x minus mean whole square divided by n. You will get the same value what you got here. Sum of you have calculated x minus mean, right? See the next column. That is the formula. This is var dot p function. I have used the function here. I am using the formula here. Okay. So if you all of you did the function, first confirm all of you have done the function. Var dot p. This is the function for function within Excel for calculating variance. Var dot p is for population. B2 colon B732. Manual calculation, sum of column C divided by n. Excel is also very, very important. That's why we are taking it. Excel, without Excel, you can't work in data science. Initial analysis is all done in Excel only. Yeah, we have to use function only, but formulas also have to be known. In some interviews they're asking the formulas also. In some interviews they're asking formulas also. That's why hope they don't ask the formulas, but they are asking what is the formula for standard deviation, formula for skewness and kurtosis. They're asking. Okay. Got this? This is the manual formula. This is the manual formula. Sum of the x minus mean whole square column divided by count. No, they will ask you the formula. The formula is this. The formula you have to remember. The variance is sigma x minus mean whole square divided by n or n minus 1. Standard deviation is square root of sigma x minus mean whole square divided by n or n minus 1. Square root of variance is standard deviation. The advanced profiles, they will definitely ask these basic formulas. Even in MCQ test, they are asking. In MCQ test itself, they are asking the formulas. Rounded off option is here. Below general, decrease decimal. Decrease decimal and increase decimal. Dots arrow will be there. Below general on top. See, you can decrease decimal, increase and decrease decimal. So all of you got the formula for variance. Sigma x minus mean whole square divided by n. Standard deviation STDEV dot P. B2 colon B732. STDEV dot P. Or manually square root of variance. You will get the same value. STDEV dot P. All right. Standard deviation is equal to sq dot p b2 colon b 732. Excel functions you need to remember. All Excel statistical functions you need to remember. These are all statistics only, na? These are all statistical functions. What we are using are all descriptive statistics. The functions you have to remember. Square root of variance, SQRT, and select the cell where you have calculated variance is equal to SQRT, and then select the cell where you have calculated variance. You want to calculate manual skewness, x minus mean to the power of 3 is equal to open bracket x minus mean fn f4 to the power of 3. Okay, then is equal to sum of D2 colon D 732 divided by standard deviation to the power of 3. Oh, we got a different value here. Huh? Oh, n into. So this is the manual formula for skewness. This is the manual formula for skewness. X minus mean to the power of 3 cube. Calculate and drag that down. Then sum of B colon B3 72 divided by open bracket G2, number of observations into standard deviation to the power of 3. So we have negative skewness. Negative skewness means the peak will be on to the right side. The peak will be on to the right side, slightly closer to 0. Now it will be slightly towards the right side. G10 is standard deviation, na? S by 3. S3. What is formula? Skewness is equal to sigma x minus mean q divided by standard deviation q. Standard deviation q. G10 is what? Standard deviation to the power of 3. Standard deviation q. Similarly, kurtosis same formula, only thing is 4. Kurtosis sigma x minus mean to the power of 4 divided by standard deviation to the power of 4. Oh, sorry, n I'm forgetting. Don't know why. N into N means number of observations. N into. N into. N into. See, you should have a good Excel skills. VLOOKUP is used in data science. We have to use VLOOKUPs when you're looking at multiple sheets, matching dates. Recently, one of the students got data. I'll show you after the break, where he has to do a lot of things in Excel also. And then they asked him, you choose. You want to clean the data in Excel, or Python or R, whatever you want, clean the data, and then do the analysis. In Excel, you can clean because there are dates are not matching. So they asked us to take the data of only matching dates. Some one sheet dates include Saturdays and Sundays, or some data is not there. For some dates, data is there in the sheet. So you have to take the data where dates are same. So what we will do, you will use VLOOKUP between sheets and you get the data and then you use. But in Python, we have VLOOKUP also, but it is a little bit complicated. So it's better to use Excel to clean the data. Once you gain expertise in Python, you can use directly Python. But Python VLOOKUP is functional. What you have to write a loop and then you have to execute it. Little bit of coding is there. There are libraries which help you to do that. Data cleaning libraries are all there. In Python, you can use those libraries. That will help you to do the VLOOKUP automatically. So that's there. So Excel skills are equally mandatory. No, they will clearly give you the questions also. The format of the questions also will be given very clearly. Just let me show you. See, these days recruiters are very careful. They laid off all the people who they recruited initially because they were not able to do some basic tasks. That's why what they are doing now is they are very carefully recruiting people with lot of see, complete the task section below. See, very basic. Calculate the time in days. Highest number of unique customers. Unique you can find in Excel also. Data validation in data tab. Unique records. You can find them in Python also. Then you can see here. Third highest average price amount. What is the average amount? They asked you choose Excel, you choose R, you choose Python. Your choice. But we want answers to these questions given very clearly. And they have given the data sets as both Excel file and CSV file. And see, they're saying which city has the third average first deposit amount and what is the average amount. And then plotting graphs, conversion rates, limit answer to 2 decimals. See the amount of detail they gave. They gave, see 2 decimal point percentages. So they give you very, very detailed tasks and you have to do it. And some here onwards, they say pandas data frame. They asked you to do Python. These tasks he has to execute in Python. The above tasks, if Python or Excel, but these are mandatory in Python. So they give very detailed tasks and these are your recruitment, before recruitment. This guy is in the round 3, your PJ 23 batch. So he is shortlisted and he is going through the next process. So they'll give you very detailed tasks, what to do, which method, which softwares, everything. And they expect you to follow the instructions very clearly. Log normal. It's a startup. They are working on healthcare as well as agriculture data. So startup is the once you work a one project in startup, your exit will be good. Then you'll get into bigger companies with higher packages. Startups will give you very good. They pay him 30 or 35,000 per month. If he's already working in Infosys, it's less, but he's still ready to go for that. Only thing is you work 6 months or 1 year, then you will get a good opportunity in any large company with a very high package because you have a project experience. That is what more important. Prior batches also 17, 18, they all changed companies within 6 months with double, triple packages. So it's all about learning. If you learn, you understand the whole project cycle, do one complete project cycle, then you will handle any data. That is what we found. So if your basics are not correct, companies can't help, we can't help. We have people coming back, companies are saying they are not able to perform. The problem was they didn't learn things properly. Now they have lost time, they are now learning again, sitting for placement again. So it's all up to you. See, you need to handle the data. You can't say no to the client or you can't commit to the client, which you can't do. In data science, we have a thumb rule. First, you need to execute and try. Once you got output, then only go to the client and say, I will do this. Without trying, never commit to the client. Because once you try and you found out that there are a lot of issues and you go to the client will simply say, you agreed upon this, why are you coming back to me? So the thumb rule is, once you get the data, you do all sorts of analysis, trying, find out the errors, mistakes, what all you get a clean outputs, those only you will go and commit. If there are errors, missing values and all, you clearly tell them, I found these errors, these things, then you set up a discussion, what you should do, agree on email, what should be the strategy for doing it in writing. Then only you will implement that strategy. Okay, we will replace missing value with mean. In email, you take a confirmation, then replace the missing value with mean. That is what you have to do. Don't commit. So people look at the data, they don't understand, they will agree to all the client, whatever says. Once the delivery date comes, they fail. It happened with a lot of students. They keep on calling me. I tell them, when you get the data, you implement. You understand, are you able to calculate descriptive statistics? If you can do that, go to the client, I will do descriptive statistic analysis. I will do EDA. I will do pre-processing. I will build regression model. You have to have actual model built ready for you. Then you go and commit to the client. Without trying, without doing anything, you don't commit the client. Because if you fail, he will put the blame on you and company will put the blame on you. So once you get the data, these are the steps you need to follow. These are the same procedural steps. Now, if you're in Python, you don't need to do this. For understanding of basic formulas, I'm doing in Excel. If you are happy in Excel, you can do the basic analysis in Excel also. You can do basic analysis in Excel because Excel now has 10 lakh rows and it's faster. So you can do basic analysis in Excel. Come up with the what all things you have, and then accordingly you will start the discussions with your client. So that is the thumb rule. Don't commit without you experimenting or trying anything. All right? So these are the ones. We will go through those functions. We look up index match, if statements, if and if for, all those things will be there. Basic Excel, data validations, unique records, sort and filter. All these things are there. Date is most important in Excel. Sometimes in Python and R, we can't do date modifications. We go back to Excel and do the date modifications. Dates, formatting of dates is easy in Excel. You can do it in R and Python, but now Python is easy, equivalent to Excel. R still has some issues. R also has libraries where you can implement this. So dates is very, very important because in most of the data, you will get dates. In this data also, we have dates, but we have extracted information from dates, like weekday, based on the day, whether it is Sunday, Monday, you can extract. Month, what month is, you can extract. What year it is, you can extract. What quarter is extract. If you have mapped the holidays list, you can extract whether it is a holiday or not. All those things can be done. Okay. So it's 11 o'clock, you take your 15-minute break and we'll meet at 11:20 or 11:25. Okay. Take your break. is KURT. KURT B2 colon B732. All right. Now the quartiles is equal to quartile open bracket B2 colon B732 comma 1 for first quartile. So all the observations till 3152 will fall under first quartile. Is equal to quartile open bracket B2 colon B732 comma 1 for first quartile is equal to quartile B2 colon B732 comma 2 for second quartile or median. From 3153 till 4548, it will be second quartile. All right. Is equal to quartile B2 colon B732 comma 3 for third quartile.
So what is quartile or
Excluding and including, that is different calculations. You can exclude top 10%, bottom 10% and calculate quartile like that. Or you can include exclude. Hello? Yeah. Yeah, I'll take the exam as it is, as scheduled. Okay. No problem. If everybody leaves, everybody will get 0. That's for that particular evaluation. You can anyway skip 2 tests. Your choice. Okay. Yeah, see, you can skip up to 2 tests. It is best 4 out of 6 evaluations. So if you want, you can skip, no problem. But test is as scheduled at 220. Yeah, that's what I know that, but I have announced the test, you have to take it. And your midterm will be on between 21st and 23. 22nd most probably. Yeah, that's what. You will get it now. After putting comma only, you will get it. Your old versions you will not get. 3 is quartile. Interquartile range is Q3 minus Q1. Third quartile minus first quartile is interquartile range. Q3 minus Q1. Yeah, same thing. It's equal to 731 divided by 4. The data is already sorted. We have sorted for median, right? The data is already sorted for median. So if you round it off, 183 observation would be your first quartile. So if you scroll down to row number 183, in our case it is 184. The value is how much? 3141. Oh, sorry, 3152. I think we have to go to 180. How much we got? 3152. Oh, I think it is using approximation between these two values. Approximation of these two values, you are getting it. So if you take the summation is equal to Q1 3152. It is taking approximation of the two. Okay. Q1 is 3152. 183rd plus 184 observation divided by 2. 183rd plus 184 observation divided by 2. Same thing here. This is 2 into 731. Sorry, what is equal to? Is equal to 2 into n by 4, right? 731 divided by 4. Board mass rule, you don't need to give brackets. 366th observation, right? 366th observation. In our case, it is 367. This one, 4548, right? 4548. See, this will be 3 into 731 divided by 4. This would be, if you round this off, it will be 548 observation. So if you scroll down to row number 548, you will see 549, 5936. 5936, 56. So approximation. It is again taking approximation. Based on the decimal, no? What is the value we got? 548. So is equal to how much we got? 5956. That means it is the second value. Oh, by 4, right? So the valuation is going down. 1 second. These two, I think, is the value. Yeah, this is the value. 549 and 550. Because one down, no? CNT is the first row is header. So 549 plus 550. So you can see the average 5956. You can see the bottom average 5956. The two values. Okay. Standard error is equal to standard deviation divided by square root of number of observations. Standard deviation divided by square root of number of observations. So standard error will tell you the difference between population mean and sample mean. What is the variation between population mean and sample mean? Which means if you repeat the test with new data, how much mean difference you will get. standard error is variation between population mean and sample mean, which means if you repeat the same test with new observations, how much the mean can vary. Not that it will exactly vary by 71. It might vary somewhere between 71, closer to 71, below or upper. So it just tells you how much variation can occur in the sample mean compared to the population mean. That means once you conduct the test with some set of observations, you get a mean. You repeat the same test with new set of observations, what will be the change in the mean? That is what standard error tells us. Because once we build a model, we test it and we run it on different sets of new data, right? There we also need to understand standard error. How the new data standard error mean changes. If there is a too much change in the mean, that means you have to bring changes in your machine learning model also. If the mean is not that changing, it is closer to the existing mean, then you can run the same model. So that's the purpose of machine learning model, right? So I built a loan model. Every day I'll get new set of data. You know, loan applications, right? Loan apps. You just give your mobile number, PAN card number, right? How these loan applications evaluate? First, they check your credit score. They are rule-based systems. What is the rule? If your credit score is 750, your loan application is 50% approved. Second, they will ask your existing EMI, your income and existing EMI. Both they will ask, right? Your salary and EMI. That means they will calculate loan to income ratio. Loan EMI divided by total salary. Total EMI divided by total salary. That we call it as LTI. Loan to income is closer to 60%. Less than 60% or 60%, your loan will be instantly approved and you will get your money in your account in seconds. If LTI is greater than 60%, say 80% LTI is there, they will not approve the loan. It will say over leveraged. You already have taken too many loans, your money is going into more MMS, will not. So you need to understand that LTI percentage mean averages you have to closely monitor them. Sometimes for some set of customers, it will be higher. Inflation is high, right, nowadays. So your income, loan, your interest rates are higher. So your EMIs will also go up, right? Initially, LTI was only 0.40. Anything above 0.40, they never approve the loan. But now what interest rates went up? Your home loan EMIs go up automatically without you doing anything. That means you have to adjust your LTI. It has to be increased to 0.60. So now LTI is 0.60. If RBI increases interest rates again, who knows, LTI might go up to 0.70. Because as the interest rates increase, you have to adjust your loan to income ratio because EMIs will increase, right? EMIs increases, your loan amount, that LTA ratio will also have a problem. Loan to income, it will also increase. If you are paying 80% of your loans or your 80% of your salary, then it's a risk for the loan application for loan provider, right? So they have two options: reject the loan or increase the interest rate to 28% or 38%, depending upon the profile and the risk. If it is 30,000 rupees loan, they charge 48% interest, right? So there it depends on the risk profiles. And risk profile of the same customer will change every month. Not that your risk profile of the customer will be stagnant forever. No. Every month the risk profile of the customers will change based on the loans or based on the expenses, based on the average bank balances. All these things will affect the algorithms in the banking. So HDFC, ICICI, they have very, very powerful algorithms that adjust based on the changes in the customer profile. Accordingly, you might see last month some offers in your net banking. Next month, you will see that offers are not there because the algorithm will automatically adjust the offers based on your spending pattern. What was your average balance last month? Compare it with the last 3 months average balance. If it is less, offers will start eliminating. If it is good, you will get new offers. So that is how the offers will be decided. All decided by the machines, not by human beings. And all are defined by the parameters, the variables. So that is how you have to be monitoring. So monitoring of the models, you have to look at your mean. What is the actual mean? What is the new mean you are seeing? Whether it is distorted, then you have to work on your model again. Because if you give loan to wrong person, if he defaults, it's a loss to the bank. Right? So that's where monitoring is required. In monitoring, this descriptive statistics plays a very, very important role. You take the descriptive statistics of the model data on which you build the model, and you compare the descriptive statistics of the new data which is coming into the model. And if there is not much of a difference, you are okay. But if you see huge difference, then immediately you have to go and check your models. Otherwise, your model will generate wrong predictions, which will affect the business. So that sort of things you have to understand. See, loan guys have to give up loans. They can't keep the money with them, right? You know, loan application guys, they will run after you to give money. Why? Because they want, if they lend them, because they borrow. It's not their money. They borrow it from a bank, public sector bank, syndicate bank or corporation bank or state bank. They borrow 300 crores or 400 crores and they have to pay interest on it, say 12%. That means they have to lend it. They can't keep it with them, right? If they lend it to customers at 16, 18, 28%, the margin is their profit. The margin will be their profit. So that's why they'll be in a hurry to lend. These Insta loans without paper, documentation. You have apps that give loans without documentation at all, based on your credit score and your credit profile, because they are forced to lend the money as soon as possible. If you get them, if you borrowed the money, say this week, by next weekend, all the money must be disbursed. Otherwise, we'll have a problem. Because you have to pay interest next month to the bank. Where will the money come from? Your EMIs will be used for paying the interest on the loan to the bank. So that is where the whole thing happens. So descriptive statistics of the existing model and the new data which is going into the model must be checked. If there is too much of deviation, if there is too much of differences, you might have to build a new model, or you might have to change your existing model parameters. That is what you have to do. That is what is the job of the data scientist or the data analyst, to constantly monitor. So you will get all these things. What is the, once you get the new data, you check it. Before passing it into the model, you have to check the descriptive statistics and make sure everything is ready. Then you approve the data, it goes into the model, predictions will be generated, and clients will get the offers in their SMSs and emails. And how many people accept and take it? Again, it depends. Right. So you get SMSs and emails, right? It's all generated by the system. Only people will sit there and monitor whether the models are doing right job or not. 90% they will do the job. The problem comes in the data that comes into it. Data comes sometimes not, you can't control. If inflation is high, what can you do? If interest rates are being pushed up by the RBI, you can't do anything, right? So you have to follow, the EMIs will go up, spending will go up, LTA will go up. So you have to adjust the model. You have to make sure LTA is adjusted. LTAs are adjusted from 0.40 to now 0.60. There is a talk that they may go up to 0.70 also. If RBI does another rate interest next month. Next month, there is a RBI interest rate announcement. If they increase the interest rate one more time, EMIs will go up again. All EMIs, personal loan, home loan, car loans, everything will go up. So that is how the whole things work. That is the importance of descriptive statistics. Clear? Any doubts? Now, if you go to the Python, it's just one simple command which will give you the output. Yeah. Yeah. Bicycle data dot cnt dot describe. See, dot describe will give you all. Count, mean, standard deviation, min, max, first quartile, second quartile, or median, and third quartile. Now, if you want all the descriptives, print you get the skewness and the kurtosis along with the other parameters also. You'll get the exact same values what we got in Excel, right? Exactly same values you get what you got in Excel. Yeah, see, base stats is part of this program, so you have to learn it. It's part of the syllabus. We will start with basic statistics.
But in a real life, we do not use Excel for these.
But you need to understand, right? What is the mean difference? What is median difference?
It's applying a formula.
A formula is not important here. You are still not understanding. It's the interpretation which is important here. Formulas are not important. What the numbers mean is the important. What I am telling you is, you always compare these numbers with already built model numbers. You build a model, machine learning model on some data, right? For data, you have a descriptive statistics. That descriptive statistics and this descriptive statistics should be closer to one another. So, model building, you have one set of data. You get new data every time. Whenever you are passing the new data to the new model, you have to check the original model's descriptive statistics with the new data descriptive statistics, so that you don't have any problem in the predictions. If you make wrong predictions, then it will affect the business. So the formulas is not, interpretation of the numbers is what you have to look for. Suddenly the new data has high skewness. That means outliers are there. So you have to work on the outliers before you send the data to the model. Extreme values. Like what happened, 62, 65. All the students scored above 90, only 2 people scored 62, 65. They are called outliers. Extreme values. Outliers are extreme values that fall outside the normal range.
We can know both the data in zero.
Old data and descriptive statistics you will already have in your notebook. You have the new data, you have to calculate and compare with them. Yeah, Jupyter notebook only. You have to do it in Jupyter only. Actually, for that also, in pipelines, you will write a loop. Programmer will write a loop. Generally, what happens is we use something called data pipelines when you are using cloud. So whenever the new data comes, descriptive statistics will be calculated, and each metric is compared with the other metric, original data metric. If the deviation is beyond 5%, you will be given a warning. The data scientist will get a warning, and immediately he'll block the pipeline, check the data and correct it and send the data back to the pipeline.
So correction means it will not be with the data. The data that comes from outside.
There are methods to correct. Methods means transformations that all have to be applied on the data. Or sometimes you have to build completely new model itself. Completely new model also has to be built with the new data. So that also is there. So it's a 50-50. If you are lucky that new data is meeting the existing data, you will run the pipeline as it is. If the pipeline generates a warning and it blocks, if the pipeline warning comes, it will stop. It will not go ahead. In AWS, GCP and Azure, pipeline data pipelines, you have to put restrictions, constraints. If the change is bigger, it will automatically stop there and generate to all the relevant people a message will go saying that deviations are there. So all the people who are involved in it, they will come together and then they have to work and correct the pipelines. So that is what happens in day-to-day in Amazon, Netflix. There are hundreds of data scientists and statisticians whose job is to look at the pipelines, alter the data things, because if you don't do that, models will fail.
The loop is built on.
For loop, you have to sit with the programmer and build it. Yeah. So not algorithm. You have to add a component to the model. Block. We call them as blocks. A code block will be created with the loop, and that code block will be inserted in the pipeline. So data has to go to the code block, follow the changes, and then cleaned data will go to the model. So these are all technical things. DevOps and cloud guys and programmers will do it. You have to sit with them, you have to explain the formula to them, that's all. And then you have to check it, test it, whether the thing is correct or not. That is your job. So data scientists and data analysts will work with the cloud guys, DevOps and cloud guys, who will write the code block for you. You have to tell them these are the comparisons. They will they will write a loop with the comparisons and all. You have to check it, test the loop. Once that loop is giving you the right output, you will accept it, and then they will insert it back to the pipeline. DevOps guys will do it.
So first we have to cover with technical comparison.
Yes, you have to be thorough with the numbers. Your job is to monitor the numbers. If there is change in numbers, what you have to do, you have to tell the programmer and the DevOps guys. They will do the changes to the model. You can't do that. Is related to programming. Cloud and programmer will do it, Python programmer. You have to sit with them and tell them what you are, explain to them what they have to do. Once they have done it, they will send it back for testing. You have to test it. Once you say yes, then the model block will be inserted. So data is always pipeline. See, we are just running with some 730 observations. For Amazon, per minute, it will be millions of observations. Per minute. 60 seconds, Amazon has close to million observations. That means 10 lakh observations are generated. Because it's a company that works in 190 countries in the world. How many people will be accessing Amazon at a single point of time, doing transactions, searching for products? Each of those things will be monitored, right? By algorithms, because humanly you cannot do that. If you want to do that, that's what the Jeff Bezos says. Now, if there are no machines, I have to employ 1 million people. That means 10 lakh employees I have to employ for only monitoring purposes. If he employs 10 million people, can he manage? He cannot manage. Nobody can manage. If we are monitoring 10 million people all put together, if you have 50 million, 1 crore, 50 million employees, or 50 lakhs to crore employees, which company can survive? Nobody can survive, right? So machines have to be done. They invest in machines, data centers, millions and millions of servers. They take care of themselves. They don't depend on humans that much. Humans are only for monitoring purposes. Just observe. If there is any problem, you assist the machine in taking the right decision. That's all. Because humanly, it is not possible to monitor that many transactions. Because if Facebook, how many updates per minute, lakhs and crores of updates are done. WhatsApp, even bigger problem. The problem WhatsApp has is people just message, and they have to monitor each and every message. They can't do manually, right? They have to go put systems. NLP bots will be there, natural language processing bots, chat bots. They go through this each and every message you put on WhatsApp. And then they have certain rules. If the keywords will be there. If any of those keywords are coming in those messages, if you are that you are sending, immediately it will block your account. Like terrorist or something, jihad, or the keywords are there. Close to 800 keywords WhatsApp India has identified. If any of those words comes in your WhatsApp, what you call exchange, your account will be immediately blocked. A lot of people complain, no? Their accounts are blocked and all. Unknowingly, they get blocked because of they use these things, which will cause. And sometimes police people will give additional words to WhatsApp to block if there is communal issues. So all those things will be there. They can do it. No, not anybody else can do it, but they have the thing now, right? Somebody has to monitor it. That's all. That's a big lie. See, without the monitoring, will the systems run on their own? The servers and storage devices have to be monitored, right? There will be a cache history, right? There is nothing on WWE which is not saved. It is there forever. Even if you delete it, you delete your profile, still it will be there in a cache memory. It is there forever.
cache memory will be updating on the.
But still, cache memories are, see, the one which they do in data centers, they keep on adding it, right? The data will be there forever. Even the creator of World Wide Web says nothing can be eliminated from www. It is not possible for anybody to eliminate any information from World Wide Web. It is there forever. You can only block it, you can only store it, or you can save it in a particular location where people don't have access. But otherwise, everything is open to access. And every security can be hacked. Because unless you update based on the new things which is happening, your security systems also will fail. What happened with Australian insurance? You might have studied. An insurance company in Australia is hacked. Now the hackers have 2 million customers' data with them. They're threatening the insurance company. If they don't pay them the money in bitcoins, they will release the data on dark web. If they release the data on dark web, all the customers' data is there, means anybody can hack and they will be completely gone. So that Australian insurance company is not struggling. Government is saying you have to pay. Whatever they are asking, ransom, you have to pay them. Ransomware. So, because the customer data is with them. Complete customer data they hacked upon. So, there are situations like that. So, data protection is very, very important. So, when you are building pipelines or anything, you will also have to deal with another people called data governance. People will be there. Senior management people will be there. Data governance and data privacy experts. They will also sit with you and make sure your data is not. You have to put restrictions on data. You can't give access to everybody, right? So all those restrictions and all will be decided by the data governance. So governance guys will decide. Senior managers will be there. They will give you access. The customer data, if you are employed by say HDFC Bank, you can't directly work on the customer data, right? You have to download some data and keep it in a safe place. You can't take it home. You have to work it in office only on specific systems, build models and do. They won't give you laptops or anything. You have to work on the systems there and then do it. All banks have to follow the RBI guidelines. You can't take it home. So you have to work on this office system, close it, come back, and that's all. So same thing happens with clouds. The systems are completely blocked. What laptops they give now with multiple protections and layers and all they give you, data will not lie on your laptop. It will be in the cloud only. And you will be working with secured intranets, secured internet lines, not the ones which you take from Airtel and all. Airtel only gives you secured VPNs. Secure VPNs will be there. Exclusively for your organization, they will create VPNs. You have to work through those VPNs. This data is very dangerous. If it goes out, you are gone. So critical data, right? So that is what you have to be very, very careful. And data, you have to sometimes less important data also will become problematic. We don't know when government rules change. So once the government rules changes, you have to again bring the changes to the data. Okay, any doubt in descriptive statistics? These are the descriptive statistics. If you have to remember, you will get questions in interviews and MCQs in the test, compulsorily. So make sure you mug up these descriptive statistics. Follow the notes which I am giving here. This should be enough. Okay, not that you need to read the textbooks and all. Whatever is here, if you read them, it is enough. And all the references and all I have given here. The formula is there in the Excel sheet. I'll share the Excel sheet with you. You can also have. Everything will be there. Okay. So I will give you the short simplified versions. You can use them. So data visualization. Univariate plots. What is univariate? Single variable. Univariate is single variable. Multivariate is more than one. Multivariate is more than one variable. Univariate is single. Univariate plots, data visualizations. We have different plots: line plot, bar plot, pie diagram. These are all univariate plots, basic univariate plots. Then there are certain plots which are important for machine learning. The first one is histogram. Histogram is based on frequency distribution table. Histogram is based on frequency distribution table. What is the frequency distribution table? High school statistics, class interval. Remember? Class interval. Class interval will have lower limit and upper limit, and then you will count frequency, right? The bar plot of frequency distribution table is histogram. The bar plot of the frequency distribution table is histogram. Class interval and frequency. 0 to 10, 11 to 20, 21 to 30, and then you count frequencies that fall into that range, right? That we call it as frequency distribution table. Histogram identifies skewness, kurtosis, and outliers. Histograms identify skewness, whether the bars are to the left, bars are to the right. It will you can define the skewness. Whether there is a tall narrow bar is there, that is kurtosis. When there are no narrow bars, all the bars are closer to one another, less kurtosis. So you can say it. And if there are small bars at the end, indicates outliers. The second important plot is box plot. Box plot is based on quartiles. Q1, Q2, Q3, and interquartile range are required for creating box plot. Box plot identifies outliers and skewness. The position of the box will tell you if the box is onto the left side, positive skewness. If the box is onto the right side, negative skewness. Now, outliers are identified using the following formulas. Using the following formulae, the outliers are identified. On the minimum side, Q1 minus 1.5 times into interquartile range. On the maximum side, Q3 plus 1.5 times into interquartile range. Interquartile range is Q3 minus Q1. Q3 minus Q1. Box plot, it identifies outliers using these two formulas. Observations that fall outside these formula ranges will be called as outliers. So the structure of the box plot is this. See, this is the box plot. Q1, the dark line in the middle is median or Q2, Q3, and the difference is interquartile range and the limit. Any observation falling outside Q1 minus 1, this formula value will be called as outliers. They are represented as dots. In interviews, box plot is important. What is the plot that is suitable for identifying outliers? Box plot. You can also use histogram, but the primary plot is box plot. What is the formulas? Q1 minus 1.5 into IQR and Q3 plus 1.5 into IQR. IQR is Q3 minus Q1. And the position of the box. If the box is onto the left side, positive skewness. Box is onto the right side, negative skewness. You have to look at the length of the line. Got it? The third important plot, which is density curve. Density curve is based on standard normal distribution scores or density scores calculated from normal distribution formula. Standard normal distribution formula. So what it will do is, for each observation, a density score is calculated. For each observation, a density score is calculated. And then it will do a line plot of all the density scores. Now, the formula that uses to calculate standard normal distribution formula this is the formula. It will calculate using this formula. 1 by standard deviation root of 2 pi e to the exponential to the power of half into x minus mean divided by standard deviation square. For every observation using this formula, it will calculate density scores. And then it will do a line plot of this density scores. We will get a plot like bell curve. How much closer it is to the bell curve, we will come to know. So this is the formula for calculating standard density scores, also called as standard normal distribution formula. For every observation, it is calculated. We have the x here, right? Rest of all are, first you need to have sigma, which is standard deviation, pi, you know, right? 3.14 something, exponential 2.718 minus half into x minus mean divided by standard deviation square. Using this formula, scores are calculated for every observation, and then the line plot of that would be your density curve. It will tell you skewness and kurtosis. It will give you this skewness and kurtosis. Identifies skewness and kurtosis. Got it? So these three plots are important, particularly for numerical data in machine learning. These are all numerical data plots, univariate plots on numerical data. Okay. We'll do the plots now. We will use pandas plots. Okay. Bicycle data dot CNT, the variable name dot plot. Like I told you, now they are single variable plots. It can be plot on only on single variable. So CNT is the variable. Data frame name dot variable name dot plot. Plot is the function. Kind is equal to hist. Plot is the function. Within plot, you are giving the argument as kind is equal to hist. This is a histogram. And you can see 0 to 2000, 2000 to 4000, 6000 bins or class intervals, and you can see the data. So what do you observe from here? If you draw a line touching all the endpoints, it looks like to some sort of normal distribution, right? If I draw a line touching all the endpoints, to some extent, it looks like a normal distribution. If you look at our skewness, minus 0 point, it is close to 0, right? If you go to the top, we have already calculated, it is close to 0. See? Negative skewness, close to 0. So if you look at the bars, they are slightly towards the right. Right? So kind is equal to hist. No, pandas plot, you can do multiple plots. All if you type pandas plot in Google, this is the documentation. See here. You can do different types of plots. Kind is equal to line will give you line plot. Kind is equal to bar will give you bar plot. Kind is equal to pi will give you pi plot. Kind is equal to histogram. Kind is equal to box plot. Kind is equal to density or KDE, density curve. So kind argument gives you options to choose your plot type. As per the documentation, these are the different plots you can do. Kind is equal to in dot plot. This is the dot plot function here. Dot plot, and within this you can see make plots of series or data frame. This is the documentation. You can click on source, you can see the programming also. Click on source, you can see the backend programming, GitHub programming of the complete thing. Okay, so everything is open source, right? If you click on source, you'll go to the GitHub documentations. The original code, what they have written, you can see it there. Okay, so pandas is a very important library. There's documentations, user guide. You have a lot of options. See, these are all different things you can do in pandas. Import, export, indexing, you can see, right? So this thing is venting off. Yeah, no? So you can see on the left side, different things you can do in pandas. Input tools, indexing, merge, join, reshaping, working with text data, working with missing data, duplicate labels, categorical data. So there are a lot of, these are broad sections. Chart visualizations, table visualizations, time series. So within this, you will have a lot of functions. These are the sections within which you will have a lot of functions. So pandas is a very broad library which works on data frames. NumPy, when we do machine learning, we have not gone into machine learning, right? Like I told you, NumPy is used for machine learning. Primarily, NumPy plays a role in sklearn. That too, one of the library of NumPy sklearn we use for machine learning. So original NumPy, you need it for programming. When you're writing your own functions and codes, that time you need NumPy codes. So that some things we might refer to in programming. Matplotlib, when you want to alter the plot windows and all those things. Here we are using default plot window. Sometimes you are dealing with large, bigger graph, time series data or text data, natural language processing that you want to expand the plot window. Then you have to use plt.figure and then you give your parameters. Sometimes you create subplots. That means you will create this plot window into multiple plots. Say 3 by 3. That means 3 rows and 3 columns. You will get 9 plots. So subplots also you have to do. So that time PLT is used. You can also do plt.histogram. If you want, you can also do plt.hist is there. So bicycle data dot cnp. Okay. You can do that same diagram you will get. plt.hist.
So we can write that also.
Yeah, your choice. You can use pandas hist or plt.hist. Anything is same. Same graph, na? No change. Which is no change in the graph, right? Why we encourage you pandas? Because as we go into deeper analysis, you won't have time. Hundreds and 200s of variables will be there. You have a lot of time constraints. You have to do as much as possible. And second thumb rule is the lesser the code, the better. Lesser the syntax, the better. That way debugging will be easy for you. If at all some errors come up, debugging will be very, very easy. If you have pages and pages of code, you will have problems. That is why they moved it to function programming. So function-oriented programming, debugging is very, very easy. Hello? Sorry. So it's all your choice. Okay, multiple methods, but stick to the basic pandas. What I will give you will be the, based on my experience, the easy to use functions where your job will be easy. Because you will be forced to work with shorter time constraints, you know, right? You all work from industry, right? Time is limited. You will have a time limit, TATs. TATs are very important, right? So when you're working with the TATs and all, you try to do things faster, efficient with no errors. Okay, otherwise you will have problems. Similarly, bicycle. No, those parameters we can't give. We have to go to Matplotlib. Matplotlib, you can change XLab, XLim, all those things you have to do using Matplotlib. But see, if the basic pandas plot will meet the requirement. Okay, it is giving you the required things, right? Frequency and all those things. But if you want a plot where you want to play with axes, X labels, Y labels, X limits, Y limits, that means the axis size. All those things you have to use PLT. PLT is the thing which you have to use to play with XLM. Now, sometimes if you are looking at Power BI style visualizations, there is a library called Seaborn. Seaborn is a library exclusive for visualizations, similar to Power BI and Tableau. So if at all your work includes one of my students in ASCII, he got an assignment where he has to do Seaborn. The company is using Power BI. They want to remove Power BI and they want to move to Python Seaborn. Because Power BI is cost, license will cost you. Python Seaborn is zero cost. Right. One Power BI license costs you around 1,50,000 or something like that. Now they don't want to use it, commercial license. They want to move to Python Seaborn, which is zero cost. So his job is to convert all those visualizations which they are developing in Power BI into Python. Same dashboard, same things he has to create, which he can do using Seaborn. So that's what he has to do it. That's they recruited him to convert it. Thereby they want to remove the cost of licensing of Power BI. Which one? All the features you can do it in Python Seaborn also. Seaborn is a exclusive data visualization library. Whatever you can do in Power BI, similar thing you can do in Seaborn.
But here we'll have to forward and we'll have to write.
It function oriented. So if you look at Seaborn, I think you guys all do it. Import, write this Seaborn as SNS. Because I think this is part of your NumPy. So SNS dot hist plot. Bicycle data dot CNP. See? See the plot, what we got earlier and what we are getting here. This is how you get it in Power BI, right? Proper cleaned with all lines and all. See, this is not properly cleaned and all. This is just a rough plot. In data science, we just need a rough plot. We don't need to present it. We need to check for our analysis, and this will help us to get an idea of the variable. But when you're looking at visualization, you are going to put it on a PPT or a database on which decisions will be made by the management. So see here, Seaborn, SNS, same hist plot, we got the same X values, same things. Only thing is there is a little bit of formatting. The bars are formatting and looking good. You can change colors, you can do all those things easily here. Understood, right? So, like in R, we have ggplot, which does everything what Power BI will do, or Tableau will do. ggplot in R, ggplot2. We'll work on that also, where we'll do any visualization in ggplot2 you can do. Or even Power BI, Tableau, which are advanced visualizations, scientific, all those things can be done in R. So there are ways, and why they are insisting on Python is zero cost, no need of licensing permissions, nothing. You don't need to ask anybody for permission. You can directly take it, you can use it, you can create products on it, you can sell it. No questions, no licensing, nothing is required. So, whereas in case of Power BI, limit of license is one person, one user ID, 1 lakh rupees you have to pay per year. So that is the cost. You are eliminating it by putting a person working on Seaborn and making your cost zero. And once you create these visualizations, after that it's just updating, right? So this one, then bicycle data dot CNT dot plot kind is equal to box, comma, what is equal to false. You'll get a box plot. So we have an outliers, we don't have any outliers. Because there are no dots, right?
So what is that word?
Basically, it gives you vertical box plot. By default is vertical box plot. If I don't give this, you'll get it like this. So vertical box plots are difficult to interpret if you are a new guy. But if you have experience, you can go with it. But as long as that, you can go with horizontal box plots. What is equal to false? What is equal to true? Again, you will get a vertical box plot. What is equal to true or no argument? It's vertical box plot. So a lot of the previous bad guys in even Capgemini, they're converting SAS codes to PySpark. PGA 17 and DSP 26, 24, two people and one boy from PGA 18. They are working in Capgemini, Pune. Their job is to convert SAS. Their existing client is using SAS. That has to be converted into Apache PySpark. Because Apache Hadoop is zero cost. PySpark, Python Spark, they have to convert those code blocks into Python Spark. So they get code blocks every week. They have to convert them into PySpark codes and send them back to the clients. They will update their pipelines accordingly. So their TAT is by end of 2023, they don't want to renew the SaaS license. Each SaaS license with a server costs you 15 lakhs. Commercial license, 15 lakhs. SaaS. Yeah, one license costs you 15 lakhs, commercial with servers. Because it can't be run on your normal systems. Which one is lifetime? SaaS is lifetime 15 lakhs. As and when update comes, you have to pay 1 lakh. Update means major update. Version update comes, if you want it, then you have to pay pricing difference from 1 lakh to 2.5 lakhs, depending upon the version level. Only companies can use. Companies which are selling products on that commercial license, only they can use. Personal usage SaaS is free. Suppose you are a student, you have this SaaS University Edition. So SaaS University Edition, which is SaaS on demand for academics, this is free. This is free. I can use it in my lectures and classroom thing, but I can't make it commercial products. So I have the same SaaS studio here, where I can do all sorts of analysis, what I'm doing in Python. So this is a cloud-based environment which they have given free of cost because of competition from Python and R. They are forced to give them, and they are asking us to use it. Don't use Python, please use this. Because they are losing business. Everybody is moving to open source free of cost things. Who wants to spend money? See, they also integrated Python. If you look at their things, they have done a lot of Python integration also. Here. See, SaaS Pi access. They integrated Python, they are going to integrate R. Use Python application to run SaaS. From SaaS on demand for academics. That's what happens. SaaS is the benchmarking statistics. They are the pioneer of statistical softwares. For 1960 onwards, statistical softwares means SAS and SPSS, the two major things which every university used to buy. You do any statistical analysis, you want anything to be done statistically, SAS or SPSS. SAS is more advanced. Whenever you have any upgraded, it's a German company, they are the best in statistics. Now, if you created a statistical software, if you want to test its reliability or accuracy, you have to compare the output with SAS. So SAS is approved by pharmaceutical industry because you can't use Python and R for clinical trials data. So for clinical trials data, you have to use only SAS because it is approved by the regulators and it is the most reliable software. Same clinical trial analysis you can do in Python and R also, but they are open source. Similarly, in banking, there are risk models, right? In banking, finance and all, they have to be done on SAS only because it's approved software. Most reliable. No, this is different actually. And what they did was, earlier it was only coding. Now they made it non-coding. Now you don't need to do coding. Earlier it was coding. See, we used to write the code like this, proc import file, type, like this, we have to write the code for importing the data. Now we don't need to write it. Just like, not even Python, just like your SPSS and all. So if I go to the, if I have data like this, I have data in my folder. So these are the data sets which I have. So this is the data which is here already. You can double click on it and then you run it. You will get the data. The output data is like this. See? So it's a click of a button. No need of coding, but the code you can see. The code is also there. See here. This is the code which is generated for the import command. Earlier, 3 years back, we used to run like this. Proc import data file is equal to ref file and all. We used to do that. Now it is all click of a button. You will get your data. And you can run all the tasks, most of the tasks that are there, statistics, linear models and all, but you can't predict. So if you're looking at graph, see bar chart, histogram, histogram, box
All the
plot,
features in Python.
not that way. All the features of SAS you have in Python. That is the way you have to look at it. SAS is the benchmark. SAS guys are very old.
So we have library.
Yes, in SAS we have libraries.
Sir, for data science, then it will be good.
SAS cost, no, I'm telling you, SAS is very costly. Companies are moving away from SAS. They are forced now. SAS has reduced the price also. They brought the licensing fee to 7 lakhs or 8 lakhs also now. Because they are going out of business because of R and Python. Pure open sources and large scale integrations into Azure, AWS, and GCP. They are better compared to.
How is Python?
Which one?
Python.
Python makes money from donations, communities and all. If anybody, so what happens is, if anybody built a product, they share royalties with the Python group. It's a community, non-profit organization. A group of people run it, mostly academic and other people working in other companies. They monitor and run it. For running the infrastructure, they take money only for servers and storage and all those infrastructure, hardware infrastructure, they take donations. So people who build products on Python, they share royalty, 10%, 20% with the Python base. That money is used for upgradation of the servers, hosting servers, the software upgradations. But everything is governed by community, mostly universities and companies like IBM, investment banks like Goldman Sachs, Bank. They all have people who work on this Python course and they share them with people. It's a community-based system, R and Python both. In fact, if you are doing PhD in computer science in R and Python in machine learning in US universities, you have to submit your model code in R and Python. They will be sent to community to check whether the models are reliable or not. Once the community gives the feedback that they are true, then only his PhD will be approved. That's how they are running the things. So if anybody created a new model, that model has to be coded into Python and R, released to the community for 6 months. It will be tested, feedbacks will be taken, and then the final approval will be given for the library to be loaded in the network. So there is a clear-cut process of how libraries are approved. There are methods to test, and those once you meet those standards, then only the libraries will be approved in the Python environment. Almost 50% rejection is there. 50% of the libraries will be rejected if they don't meet the basic standards. That's why companies are going after Python and R. Not that every library you give will be accepted. They have to go through that process. And if any of the standard is not met, they'll reject. You can see all the rejected libraries in GitHub because the documentation is not there, or the formula is incorrect, or the output is not matching with the SAS or any other software output. Then they will reject the libraries. So the last plot, bicycle data dot CNT dot plot kind is equal to density. Now you can see the density plot. See, is it normally distributed? It's not normally distributed. There are two additional peaks. Tri-model. This is a tri-peak model. 3 peaks are there, no? 1, 2, and 3. So this is not normally distributed, but closer to normal distribution. Somewhat closer to normal distribution. So you just need to upload the file, the IPNB file directly. So for GitHub, what you have to do is, so once you have this file, you start a new repository. In GitHub, once you create login, you have to create a new repository. The name should be unique. Okay, you say EDA PGA 24. Let it be private or public, you can choose. Create new repository, right? Once you create this new repository, you have this, see here, upload an existing file. Upload an existing file. So what I will do is, first let me download EDA PGA 24. So Jupyter notebook file. File, download as IPNB notebook. Download as IPYNB notebook. Now you go to GitHub. After creating the repository with a name, you will see upload an existing file. Choose files. In downloads, I will take the IPNB file. Open. Okay. Then commit changes. See, it is uploaded. Now, if I click on it, you can see all the things which I have done, the notes, see, outputs, everything will be there here. This is the GitHub profile with all notes and all. You can see here. You have to send the link, your profile link. So my name is, this is the one, github./ this what you call GitHub with your name, unique name. You just need to get this link. In this, you see the projects, Big Mart regression, taxi data analysis, EPJ2. Your projects will be here like this. Then they can click on each of the project and check. Say, for example, taxi data analysis, what I have done. Power BI Tableau, you cannot save the file. Power BI PBIX files, I don't know whether they are properly exporting, importing or not. But Python, IPNB and R files will. So this is my New York taxi data, green taxi. We'll work on this data. So you can see here what all analysis, what I have done, what models I have built, everything will be there. So the recruiters can see what I have done, what everything is there here. I can explain. If they ask any questions, we can do the explanation. But whatever here you are putting here, you should be able to explain. So in this is the regression data. So we built all regression models. So we split the data dependent variable total amount per trip. See, it is skewed, right? Skewed data. See, outliers. So I tried logarithmic transformation, but still there are outliers. I did the logarithmic transformation. For positive skewness, we do logarithmic transformation. Still, it is not working. Square root transformation also I tried. It didn't work. We have a lot of outliers. So I did a linear regression model. It failed. Then I've used models like decision tree, which are not affected by skewness. See, 0.88. Then I've used random forest model with 94% is the best fit model. Actually, we have other models also, gradient boosting, neural networks, and all those models you can build and you can use them. And at the end, you will do a comparison metric. Like one of my other student did it. You can look at it, this profile. He worked on healthcare data. So Medicaid data also will work on this data. This is live data given by government of US. So he has, see, this is how he has to, aim is to predict the, so you have to create a project like this, what you are doing, what is the definition, what you are doing. Aim is to predict the Medicare allowed amount. There's a dependent variable. And then he has done a lot of, see, visualizations, heat maps, skewness and kurtosis, metrics for understanding the data, hypothesis testing, then chi-square test, data transfer, model building and ideology. So linear regression he has built with transformation, without transformation. Ultimately, he has also used natural language processing model also. Finally, he built a comparison matrix like this is done in Excel. Excel, see, linear regression, model accuracy 64.43. Cross validation means repeated testing 63.83. RMSE is very less, 1.39. Decision tree with log, without log transformations. So he has done a complete model things, and then this is using natural language processing. So he will, after the conclusion, he said gradient boosting model is the highest accuracy compared to other models and reliability of 1.9. This is the end-to-end project. This is how you have to do. So he has also used NLP, natural language processing. We will do later. Before that, you can use regression models and then you can do it. So his interview was all done on this only. On this single note workbook, he was asked for 1 hour various questions regarding hypothesis testing, regression, and all. He was there. Next day morning, they asked, release the offer letter as a probationer. Probation period will be there, na? 3 months probation period, 30,000 or 28,000 something they paid. Before 3 months only, they confirmed him, offered him a 4.5 lakh package. After 6 months, he got a good offer from another company. Now he is working in another company with around 9 to 10 lakhs package. So within 1 year, he changed 2 companies. So that is how it will work. So you have to, it's a process, constantly start working on your GitHub profiles. Okay. You can add, as and when you delete the old notebook, upload the new notebook as we add the models. But you have to have complete a process, the flow which I showed you, that process flow, you have to flow in that. So all the people who follow the procedures, who are the GitHubs, they are all recruited and they are all working in companies. And who didn't follow, they are still struggling for placement. Their concepts are also weak. Recruiters are saying they don't know anything, we can't do it. So if you are not able to answer questions, what can we do? If you can't complete the assignment which they send you, you can't help, right? I may suggest you something, I may give you some ideas and do it, but I can't do it for you, right? So that's what. If your assignments and all, I'll guide you what process, whatever it is, but ultimately you have to do and you have to explain to the client. That is more important. Whatever you can't explain, please do not put it there. Whatever you can explain, even though it's a basic model, put it there. Because if you can't explain, they say you copied it. That's a very bad thing, right? So avoid those things, right? Not that you will understand everything, because this is a very large subject area, right? You choose what you are comfortable with and stick to them. Okay. So I'll send you this notebook. I will upload the video also.